Welcome to a video about a theorem regarding a point on a perpendicular bisector. Here we can have a little visual of what's going on. We have a line segment AB, and we have a segment, or we have a line CD that is it's intersecting this line orthogonally or perpendicularly. So, and we also have some distances given to us. The distance from A to C, from B to C, from B to D, and from A to D. And we can move this point C around and you can see what's happening to these distances. All right, nothing special really seems to be happening. There's not really much of a relationship that's obvious here. But let's see what happens if we continue to move it this way. Oh, something special just happened. And that is that this point now has become the midpoint of A and B, which means that this line CD, is now a perpendicular bisector of the segment AB. Thus, point D lies on the perpendicular bisector. Now look at this, the relation between AD and BD. The distance from A to D and B to D is now the same. So, and that it turns out that this is always true, that if a point lies on the perpendicular bisector of a line segment, then it is always equidistant from the endpoints of the line segment. And that's an if and only if theorem. That means it goes both ways. So here's how it goes. For going one way, if a point is on a perpendicular bisector, then the two triangles formed by the bisector must be congruent. And here's how. The bottom two sides are congruent because the segment is bisected. The vertical side is shared and is thus congruent to itself. The angle between them is a right angle due to the definition of perpendicular. Thus, the triangles are congruent by side angle side. Since the triangles are congruent, then the distance from the endpoints to the point on the bisector must be also equal. So we've proven it one way. Let's go the other way. Now, let a point be equidistant from the two endpoints of a line segment. Draw a line through that point that is perpendicular to the segment. We now have two triangles. Since the point is equidistant from the two endpoints, those sides must be congruent. The perpendicular line is shared and is thus congruent to itself. The angle between the perpendicular line and the segment must be a right angle from the definition of perpendicular. Thus, the two triangles must be congruent by the hypotenuse leg theorem. Since the triangles are congruent, then the intersection point between the perpendicular line and the segment must be equidistant from the two endpoints. And thus, the perpendicular line has got to be a perpendicular bisector of the segment. We've gone both ways now. So here is the final statement of the theorem. A point is on the perpendicular bisector of a line segment if and only if it is equidistant from the endpoints of that line segment.